Section 4.7, inverse trigonometric functions. So we're done graphing trig functions now. This is going to be more related to what we talked about in sections 4.1 through 4.4 with using reference triangles and things of that nature. Starting with some definitions here that you need to be aware of. Arcsine or inverse sine and arctangent or inverse tangent are defined only over the intervals from negative pi over 2 to positive pi over 2. Arc cosine or inverse cosine is defined over the interval from 0 to pi only. So first thing, whether we write arcsine or inverse sine, those mean exactly the same thing. Arctangent, inverse tangent, those mean exactly the same thing. Arc cosine or inverse cosine mean exactly the same thing. When you are drawing reference triangles for these inverse trig functions, remember all students take calculus, that will help you determine where these are going to be drawn, except for the tangent, it will not help. Reason being, when you're dealing with the arc or inverse trig functions, remember, first of all, that you will never use quadrant 3 for a reference triangle. Okay? If arcsine, arctangent, or arccosine are positive values, then you are going to use quadrant 1. Anytime that you're dealing with an arc or inverse trig function and it's positive, you will draw it in quadrant 1. Let's start with cosine. Well, if cosine's negative and we can't use quadrant 3, all students take calculus, tells us that the only other quadrant in which cosine is negative is quadrant 2. So this is where you would draw your triangle for arc cosine or inverse cosine when it is negative. Sine function. All students take calculus. If we can't use quadrant 3, the only other quadrant in which sine is negative is right here. So we're going to draw negative sine values there. Now tangent, this is the one where it's going to cause you some problems. All students take calculus. Tangent is negative in both 2 and 4, but by definition, it's only defined from negative pi over 2 to positive pi over 2. So inverse tangent, when it's negative, has to be drawn in quadrant 4, not quadrant 2. So your all students take calculus help you with every single one of those except for arctangent, you need to remember, is associated with quadrant 4 when it is negative because of how it is defined. Evaluate without using a calculator. Arc sine of negative 1/2. Arc sine, we can't use quadrant 4. Has to be negative. All students take calculus. Has to be drawn then in quadrant 4. Arc sine, opposite over hypotenuse. You should recognize this triangle. Our reference angle is going to be 30 degrees. So now when you give your solution, remember from our definition that arcsine's solution has to be between negative pi over 2 and pi over 2, or negative 90 degrees, positive 90 degrees. So when you name this, you cannot call it a 330 degree angle because it's not in the defined values for arcsine. This is a rotation of negative 30 degrees or negative pi over 6. Inverse sine of 3 over 2, value is positive, so it has to be in quadrant 1. Opposite over hypotenuse. Once again, you should recognize this triangle. Reference angle is 60 degrees or pi over 3. Inverse sine of 2, positive value, has to be in quadrant 1. Sine is opposite over hypotenuse. You should recognize a problem with that triangle right away. We know if that's a right triangle, is it possible to have a side opposite larger than the hypotenuse? No. So this has no solution. This can also be related to all the work that we just did with graphing. When we graph the sine function, Sine function fluctuates when there is no amplitude change between the values of 1 and -1, so it never reaches this value of 2, so that's how else you would know that there is no solution to that. Letter A here, arc cosine of root 2 over 2. Arc cosine, this is a positive value, so we know our triangle has to be here. If I go adjacent root 2 over hypotenuse 2, not a triangle you recognize, so we need to derationalize this. 2 over 2 root 2, which becomes 1 over root 2. Now if I go adjacent over hypotenuse, you should recognize this triangle as being 45 degrees, or pi over 4. Arc cosine of -1. Where is cosine equal to -1? Anytime cosine or sine are associated with -1 or 1 or 0, you're talking about a quadrantal angle. What quadrantal angle? Cosine is the x-coordinate. So where is the x-coordinate -1? Right there. How do we name that rotation? That's a rotation of 180 degrees, or pi radians. Arc tangent of 0. Anytime arc tangent is equal to 0, we have to be talking about a quadrantal angle. When that is 0 or undefined, remember tangent is sine over cosine. So if arc tangent is going to be 0, that's going to happen wherever sine is 0. Where is sine equal to 0 at? Sine is the y-coordinate. Right there at 0 degrees or 0 radians. Evaluate using a calculator. Okay, we're going to find both the degree and radian measure here. So let's go to our calculator, plug these in. Let's first find all of them in degrees. So we're in degree mode. Arc tangent of -8.45, that is when you use the inverse, so second function tangent, -8.45. There's the degree measure. Let's actually change to radians right now and find that. So I'm going to go to radians, hit enter, pull up the same entry we just put in, hit enter, there's the radian measure. Do the same thing for arc sine. We're already in radians, so let's do that first. Inverse sine of 0.2447. There's the radian measure. Change the mode to degrees. Pull up the same entry, hit enter, there's our degree measure. Finally, the last one, arc cosine of 2. We're already in degrees, so let's stay there. Inverse cosine of 2. We get a domain error. Same reason, adjacent would be 2. Hypotenuse 1 is what we had in the previous one. That can't be done. That's why you get an error message there. So let's record those solutions. Arc tangent was -83.251 degrees, or -1.453 radians. Arc sine was 14.164 degrees, or 0.247 radians, and this has no solution. Write theta as a function of x. Well, looking at this triangle and using our right triangle trigonometry, so Katoa, we know the side adjacent. We also know the hypotenuse. Adjacent and hypotenuse are related by cosine. So the cosine of theta equals adjacent over hypotenuse. We want to solve for theta. When we solve for theta, this is when on your calculator you would use inverse sine, cosine, or tangent anytime you're finding an angle. So technically to solve here, just like we solve any equation, we do inverse operations. I need to take the arc cosine of both sides. When I take the arc cosine of cosine, they cancel, leaving me with just the angle theta, equals arc cosine of 4 over x. Letter B, trig function we're going to use here that relates to side opposite and the side adjacent is tangent. So the tangent of theta equals opposite over adjacent. We need to get rid of the tangent. The opposite of tangent or inverse is inverse tangent or arctangent. So we get theta equals the arctangent of x plus 1 over 10.